Hello, gorgeous. We're on chapter 12. We move on to skill number 4. Okay. So make sure you check the description box down below. I have a link for the handout, so you can download the handout and use it with this video. Okay. All right. Once you have the handout, let's go. So let's talk about the making an alcohol. Okay. So making an alcohol super simple. You can do an SN2 reaction like this. Okay. Substitution reactions. You can do SN1 reaction too. If this carbon, the alpha carbon is tertiary, SN2 doesn't work here. Okay. You can also do addition reactions to make an alcohol from an alkene. We have Markovnikov, two Markovnikov here, and this anti-Markovnikov here. The new reactions that we will learn to make an alcohol are these two down here. Okay, let me talk a little bit about the first one real quick. So we have seen a straight hydrogenation on an alkene, hydrogen gas and palladium, nickel, platinum. Okay, works just fine for an alkene. Doesn't work so well with the carbonyl carbon. It's not carbon and carbon. Okay, this one carbon and oxygen. They have slightly, well, quite different property. All right, but if you force this reaction by adding high heat, that's why it's less common. Okay, the reaction go just fine. All right. Anyway, so we're not going to talk a lot about this. This is in addition. We'll learn about all this from alkene reaction. We'll focus on down here, these two down here. Okay. So two new reagents. We have sodium borohydride, look like that, and lithium aluminum hydride. These two, sodium borohydride and lithium aluminum hydride, okay, are hydride sources. Okay, they give away hydride. Hydride is a hydrogen atom with 2 electrons. Okay, not a hydrogen atom like H and just one single electron. That's just hydrogen. Is it this I got 2 electrons or a lone pair. Okay, it's not. These two are not proton source. Okay, proton source is like an acid, give away a proton. All right, so like methanol, ethanol, water down here. This is a solvent, will act as a proton source. You will see in a bit, or the quenching step right here of water or hydronium ion. These are proton sources. Okay, all right, we'll talk about the mechanism of this one. Okay, but notice that lithium, when you use lithium aluminum hydride, step 2 quenching step is required. Remember quenching step from an alkyne? Okay, similar to that. We'll get to the detail. All right, let's draw the mechanism together. Really focus on this mechanism because they are similar, very similar. And then there's another reagent after this. They have, I'll say, almost identical mechanism. Okay, let's focus on this one together. So let's spend time on it. All right, so we start out with the cyclopentanone, adding sodium borohydride as a reagent, hydride source, and the proton source solvent is methanol. Okay, first step is we take sodium borohydride and then type hydride attack onto the carbonyl carbon. When we draw this, hydride is a hydrogen atom plus a lone pair, 2 electrons. So we start from the middle of this bond, attacking the carbonyl carbon. There's a hydrogen and 2 electrons. Okay, then simultaneously break the pi bond, go up to the oxygen, you get an oxide. This is an alkoxide. All right, we're done with the sodium borohydride. Now methanol will be a proton source. Okay, so pronation, and that's the product. The red hydrogen comes from the reducing agent sodium borohydride. Okay, the black hydrogen comes from the solvent. All right, that's how to make an alcohol. Move to the next one, lithium aluminum hydride, just alike. Take a look, just alike. Attack the carbonyl carbon too. Okay, all right, so you get this hydrogen down there, this is hydride down here, and then pronation from the second step. Okay, add an acid, add a water. That's fine. That's an alcohol. That's from the reducing agent. All right, one main difference between these two. Okay, and you need to know. One, lithium aluminum hydride is much more reactive than sodium borohydride. Yeah, you wouldn't know, right? So that's why I have to tell you. Okay, so it's so reactive that you cannot add lithium aluminum hydride with a proton source. Okay, in sodium borohydride you can mix with methanol, water, ethanol. Those are fine with a solvent, but you cannot do that with lithium aluminum hydride. If you do that, take a look. Okay, lithium aluminum hydride is so strong, attack the proton of water, attack proton of alcohol, turn it to be unreactive aluminum hydride and hydrogen gas. Okay, because this guy is much more stable. All right, so you have to separate into 2 steps. Cannot be mixed with proton source. Okay, step 1, step 2 gonna be clear. In sodium borohydride, you can use them together with the solvent. All right, a little bit about stereochemistry. So this carbon is an sp2 carbon, trigonal It is flat. Okay, which means that the hydride can attack right there from the top face, get you to this product. You know? Or from the bottom face, get you to that product too. Okay, so some carbonyl carbons can create a chiral center. So carbonyl carbon, some of those we call them pro-chiral. It's not chiral yet, but it will become chiral after the reaction. Okay, so racemization could happen because of, just like carbocation, this carbonyl carbon is flat. Okay, alkene, same thing, sp2 trigonoplanar. Okay. All right, let's move on to skill 4.2. We have learned how to use sodium borohydride, lithium aluminum hydride. Okay. Now, how to use it in the reaction.